So hello guys, welcome to my YouTube channel. In this channel, you will find the solution, the mathematical solution of. For this channel is mainly for engineering students. Okay, so you will find the mathematical solutions of engineering mathematics, no matter which year you are. But and I'll be posting more on other subjects as well, so do subscribe my channel. So today's my mathematical problem is so that u equals to 2x plus x cube minus 3x y square is harmonic and determine its harmonic conjugate. Okay, so this is a very common question asked in engineering. So we are going to solve this in today's video, so let's get started. So we are given that u equals to 2x plus x cube minus 3xy square. So given, since u is a function of x and y, okay, this is comma, and we have 2x plus x cube minus 3x y square. So to show that the function is harmonic, we have to find its double derivative, that is d square del square u by dx square plus d square u by dy square equals to 0. We have to show that, so we are going to find first the derivative, single derivative. So du by dx equals to 2x dedicated to plus 3x square minus 3y square, and we are further to determine its harmonic conjugate, so we need phi 1 and phi 2. Let's suppose phi 1 is a function of x and y. We are going to suppose it. Say also du by dy equals to minus 6xy equals to phi 2 is the function of x and y. Say now double derivative of du by dx is 6x constant, and this is also constant. Also d square u by dy square, for this we get minus 6x, isn't it? So to show the function is harmonic, what I said earlier is we have to show the sum of double derivative d square u by dx square and d square u by dy square should be 0. Sum should be 0. So d square u by dx square plus d square u by dy square equals to what you get, 6x minus 6x equals to 0. So u equals to x comma y, 2x plus x cube minus 3xy square is harmonic. Okay, so to find its harmonic conjugate, we have to find the harmonic conjugate. So for this we have phi 1, and we place, in place of x we place z, and in place of y we place 0. So what does this function become? Let's see. 2 plus 3z square, here y is 0, here y is 0, so we get 0. We don't need to write that. So and phi 2 equals to phi 2, this is phi 2, we have to put 0, so it becomes 0 naturally. So we have a formula equals to integration This is the formula, okay? You have to remember this. It's simple, simple. It's simple. The formula is very simple. Fz. Now we have to find the function that is harmonic conjugate. So to find that, we the function, first we find the function which is the integration of phi 1 z0, means this, and minus I. You must write I, okay? I should be there. So I phi to z comma 0 0. So yeah, that is this. And let's put the value of the function 2 plus 3z square minus I into 0. It becomes 0, isn't it? So 2 plus 3z square dz plus c dz plus c. So we do integration. So let's do integration. 2, what is that integration of 2? 2z plus 3z cube by 3 plus c equals to 2z plus 3 is cancelled out, so we can write z square z cube plus c. So this is the function fz, function in place in the form of z. We get that. So in we get a function of z in terms of z. So now what you are going to do is fz equals to 2z plus z cube plus c. It is. So we know that function z is the sum of complex of real and complex part, isn't it? So this is v x comma y equals to, so in place of z we are going to write x plus iy, okay? So x plus iy plus x plus iy cube plus constant. Don't forget to write constant, okay? Because while integrating we find some constant value and we have to write constant plus c is constant. So let's multiply 2iy and let's we the x plus iy cube, we expand this cubic form into its cubic form, plus 3i xy x square minus 3. We get the square I square and y square, so I square equals to minus 1. So I wrote here minus 1, I square equals to minus 1, and then I cube. We get here I cube. So why I wrote minus is I cube equals to I square into I. So I square equals to minus 1. So I hope you get that. You are brilliant students. Get that, isn't it? So let's separate out the terms which have I in common. So this and this term, and the terms which does not contain I. Okay, so this and this, 3x y square plus I, 2y plus 3x square y minus y cube plus c. Yeah, this is the, so we get, therefore harmonic conjugate harmonic conjugate of u equals to 2x. So so we have to find the harmonic conjugate. So the conjugate part is only this, okay? This only the I part, imaginary part is conjugate. So we write the 2y plus 3x square y minus y cube plus c, constant, because it is a derived mathematical equation of integration. So we must write harmonic conjugate. So what we learned is that to show the function is harmonic, we have to show that the sum of d square u by dx square plus del square u by del y square. So sorry, I said d, it's del. There is difference between d and del. So we have to show it is 0. So we have shown that, and to find the harmonic conjugate, first we uh, say that the du by dx and du by dy is phi 1 and phi 2. Then we integrate using this formula, and then we place, in place of z we place x and x plus iy, x plus iy, and we get the real and imaginary part. And so the imaginary part is only the answer to, if the question asks its harmonic conjugate. Okay, so that's all for today. So hope you guys like this video. Don't forget to subscribe my channel. Hope I'll see you in the next video. Okay, till then, goodbye.